Electricity and plumbing class, Mr. Voigt again. On to the next lab, lab 1B. So as you can see on here, this is the same setup that we had before. 14 3-wire, 14 3-wire. Again, we'd have a black, a white, and a bare wire inside of this cable. I should be calling these cables 14-3 cable, 14-3 cable, 14-3 cable. The only difference is last time we had our GFCI here, and this was a regular duplex receptacle, and we just swapped them. So the whole idea here is that this GFCI now, because we run the electricity to it and then from it to this outlet, this GFCI outlet will now protect this outlet. Before, when we had our GFCI here, it did not protect the upstream outlet. But when we have the outlet downstream from it, it protects it. So in other words, remember, this gives you extra shock protection. That's why you have them. Anything that's in a damp location or a potentially wet location, you have GFCI outlets so that you don't kill yourself. And so if you're, let's say, above a kitchen counter and you don't, these are more expensive than these, and you don't want to have to buy a GFCI for each outlet, you can string them together. As long as this is at the top of the run, you can string them together downstream from your GFCI. So, as you remember, we also had on a GFCI, one of these sets of terminals are what we call line terminals, and one of the sets is load terminals. Now, it will say right on the outlet which one is which. Literally, it'll be printed into the plastic. For now, I put up here, your line is your top terminals, and your load is your bottom terminals. So these are my line, and these are my load. One of them will be my feed or hot electricity. One of them will be my neutral. And here's always my ground. So anyway, we're going to go ahead and draw this. Remember, we have 14-3 terminals. We do not need our red hot. We're just going to go ahead, and this is just a junction box right now. So that's a junction, and we're going to go ahead and just pigtail these things together. Or, I'm sorry, wire nut these things together. Down here, we don't need to put these together like we did in our first lab. You literally are going to take your hot wire. Remember, our top or our line. Line means incoming electricity. That's going to go there. Okay. And then this is our outgoing electricity. So the electricity will come in here, go through this outlet, and then back out through this wire. That will go there. Then over here, this will go to my line. It's actually, as far as drawing it, it's easier. Then we need our neutral. Again, this is a current carrying wire, right? It has insulation around it. It's the white wire. So the electricity will go in on the feed or the hot and come back to our source on our neutrals here. Again, here we'll go right there, and there we will go right there. Over here, we'll go all the way to our line. Line incoming, load outgoing. And then finally, this is our ground. Again, those are all just junctioned and folded into the box. Down here, we'll come down here. But we will come off with our pigtail. And then over here, right to it. So that is how you do a GFCI outlet on our lab, where the GFCI outlet is at the top of the run. So now the electricity will come through the junction box, through this outlet, so that it gets protected by the device in there. It's really sensitive to increases in amperage. So when that amperage goes up really quickly, it turns off. If you're getting shocked, that amperage is going to shoot up real fast. So that'll turn off and save you. And then it goes out to power the other outlets. So this gets a high increase in amperage. The electricity has to go through this device to get there, and it will sense it and turn the whole system off. Your breakers in your breaker box here do the same thing. They just aren't as sensitive. They work a little differently, but essentially they're doing the same type of thing. but these aren't as sensitive as this, and you can get shocked pretty bad with the electricity going through a breaker, whereas this is not going to allow you to get shocked. Okay, that's lab 1B.